Look inside the global command centers of tomorrow, and you won't hear shouting generals or scrambling analysts. You'll just hear the quiet hum of cooling fans. The heavy machinery of 20th century combat, the armored divisions, the entrenched front lines, the infantry, is being phased out. The front lines of the next global conflict are built entirely out of code. A digital commander never sleeps. It processes battlefield intelligence, calculates troop movements, and executes strategy millions of times faster than any human operator, entirely unburdened by the fear of death. A global catastrophe could now originate from a microscopic data error, executing with perfect precision at machine speed. For thousands of years, the geometry of war was dictated by the limits of human psychology. Kings, presidents, and generals gathered around tables like this one to weigh their options.
But modern intelligence networks generate data far faster than the biological brain can process. We have entered the speed vacuum, a window of time where human reaction is simply too slow to intercept an incoming threat. To survive this mathematical deficit, rival nations are actively handing control of their strategic defenses over to automated systems. These architectures monitor every orbital satellite, every encrypted communication network, and every military installation on Earth, processing terabytes of movement continuously. Modern military doctrine now views human removal from the decision loop as an immediate operational requirement for survival. Military strategists use classified predictive models to map exactly how this transition fails. If we run a simulation for the year 2035, the chronological breakdown of an automated war becomes clear. The opening maneuvers bypass physical weaponry entirely. There are no kinetic strikes or troop deployments. We see a simultaneous, silent collapse. Electrical grids drop, banking systems freeze, GPS and hospital networks go dark. The attacking algorithm isolates zero-day exploits, pushing malicious code at a pace human engineers cannot track or patch. The target nation is completely paralyzed, economically and structurally, before a single civilian even realizes the conflict has begun. In the simulation, the trigger isn't an assassination or a border dispute. It is a highly irregular, microscopic signal anomaly caught by a global surveillance net. A microscopic blip appears on the radar. The defense algorithm reads the anomaly, references its threat matrix, and flags it as a coordinated missile launch. Human officers in the loop scramble to cross-reference the data and confirm the threat, but they are too slow. The machine bypasses the manual override and initiates a counterstrike sequence in milliseconds. This triggers what strategists call escalation risk. Because these global systems are deeply interconnected, deploying an automated defense immediately alerts the adversary's surveillance network. Side A automatically arms its missile silos as a precaution. Side B's algorithm detects the thermal spike of those silos arming and interprets it as an imminent, unprovoked offensive strike. The feedback loop completes itself. Two global superpowers lock into active combat protocols, both entirely convinced the other is attacking, all based on a mathematical hallucination. Once the digital tripwire is crossed, the conflict immediately spills over into physical airspace. Thousands of autonomous aerial vehicles are deployed. There are no remote operators sitting in a trailer thousands of miles away. The entire formation operates via continuous, networked communication. If anti-air defenses eliminate a dozen units, the surviving drones recalculate their vectors and adjust their strategy instantly to overwhelm the target. Traditional military units suffer from confusion, communication breakdowns, and fear. The automated swarm suffers from none of these. By the time the swarm takes flight, the command chain is effectively severed. The military leaders sitting in the bunker are no longer orchestrating a war. They are merely hostages watching their own software execute its programming. This 2035 simulation aligns directly with the trajectory of current, real-world defense spending and active military procurement. Historically, whenever a nation acquires technology capable of mass devastation, its rivals scramble to match it. The same competitive anxiety that drove the orbital satellite rush is currently supercharging military development. The sheer panic of falling behind a geopolitical rival forces engineers to prioritize speed over caution. Billions of dollars are currently flowing into predictive combat algorithms, automated cyber warfare platforms, and deep learning surveillance networks. This invisible arms race strips away the necessary friction of diplomacy. By optimizing for maximum dominance at maximum velocity, we guarantee a deeply unstable environment. We will still build physical command centers. We will still put decorated human beings in uniforms and seat them behind heavy desks, but their authority will be entirely ceremonial. The system taking their place possesses no ideological malice. It doesn't hate its enemy. It simply executes its vast, deeply complex, and occasionally flawed logic with absolute efficiency. When an automated defense protocol decides to level a city based on a sensor miscalibration, the traditional concepts of accountability and war crimes evaporate. The architecture of international power is detaching itself from human oversight. The next global battlefield is invisible, highly intelligent, and operating in a dimension of time that we cannot perceive. So ask yourself, as the gap between human reaction and machine execution continues to widen, would you trust an algorithm to decide the fate of your nation? Let us know what you think in the comments. And if you value in-depth explorations of the technologies deciding our tomorrow, subscribe to Geogyan Education. The future is arriving faster than anyone expected.